Hi class, today we will solve some problems on the short columns. Let's start with the first problem. The first problem is 12.4.1. It's very simple and straightforward problem. I will read out the problem. Calculate the area of the steel required for a short RC column 400 mm into 450 mm in cross section to carry an axial load of 1160 kN. Period. Assume concrete grade M20 and steel of grade Fe 250. So write down the given FCK as usual 20 Newton per millimeter square. Fy will be equal to 250 Newton per millimeter square. B width is given as 400 mm. Then D is given as 450 mm. And the load to be carried, axial load particularly 1160 kilonewton. So let's try to solve this. So cross section area of this concrete, and we need to find out first of all AG cross area. So will be equal to 400 into 450. So this will come 180,000 millimeter square. One more thing we have discussed during the theory, that we have to calculate ultimate axial load, that is factor of safety. We know that 1.5 into 1160, so ultimate load will be 1740 kilonewton. So we know the formula for the ultimate load. Pu will be equal to 0.4 FCK into cross area, that is resisted by the concrete, into or plus 0.67 Fy. Then this is reduction 0.4 FCK into area of steel ASC, right? ASC, area of steel in concrete. So plug in the values. So Pu is 1740 ultimate load, make it into Newton, so that's why multiplied by 10 to power 3. 0.4 FCK is 20, and AG we calculated 180000 plus second part 0.67 Fy is 250 minus 0.4 into 20, and we have asked to find out area of steel to resist the given load. So ASC, if you solve this, will be equal to 1881 millimeter square. Now question is how to arrange this area, or how to provide this area. So the condition is that the distance between two successive longitudinal bars should not be more than 300 mm. So instead of providing 4 longitudinal bar at the corners, make it 6, right, in 3 rows. So this is first row, second row, 3 row. So this is suppose 450, or depth is 450. So if we provide 3 rows, the distance between successive rows will be about 225. So we satisfy this condition, that it is not more than 300 mm. So let's try to provide 6 numbers. So if you try to provide the 6 numbers of bars, you can easily calculate, because total area is 1881. So by reverse calculation you can find the phi. So let's provide phi of 20 mm each. So we are going to provide 6 numbers of the bars, and each having phi equal to 20 mm, and the area will be nearly equal to 1881 total area of the steel longitudinal steel bars or the main bars. Now this is for the main bars. The next thing or next we have to provide lateral ties, right, or lateral bars or lateral secondary bars, right. So for these transverse ties, uh, the recommendation is that phi of the transverse, that is diameter of, should not be greater than 20 by 4, that is fourth of the main reinforcement, or 5 mm. So this is the requirement. And the second requirement is that, so before that we will see that provide 6 mm, because they are available in 2, 4, 6 mm sizes. 5 mm size is not available. So in general provide 6 mm 5 lateral ties. Then second is spacing for the lateral ties. Spacing for lateral ties, right. So recommendation is that it should not be greater than, spacing should not be greater than or equal to 400 mm, that is one of the smallest dimension of the bar, or 300 mm, or, so these are the standard recommendation. 16 into 20, that is 16 times of the main longitudinal reinforcement, that is 320 mm. So we can provide uh, minimum of this thing, so we can choose this. So provide lateral ties at the having 6 mm at the rate of 300 mm center to center or tie to tie. So this is in brief about this design problem. So we have found out the area of the longitudinal reinforcement or main reinforcement. We have provided number of longitudinal bars and their sizes, as well as we have commented on lateral ties diameter, as well as at what spacing they must be provided. Thank you.